Okay, the function g is given by this formula. Find the absolute max. Remember, if they just say max, it means absolute max. If they mean relative or local max, they have to say relative or local max. So absolute max of g on the interval -2 to 5. So, got this big huge box now to help us on the golden notes. I'll put that up here. That's good. Okay, so finding the absolute max of f is a process of eliminating candidates or performing the candidates test. Remember that the absolute max of f, in this case g, so the absolute max of g is always located at a critical or end point of g. Right here now, a critical or point of g is where g prime equals 0. So the grader is first going to want to see me identify where g prime is equal to 0. So I look at my formula for g right here, and I say g prime, using the formula for finding the derivative of an integral, is going to equal f of x, dx over dx, minus f of -2, dx over dx, d of -2 over dx, so I find that g prime is equal to f. You don't have to write out this statement, but as soon as the grader sees that you have this, in this particular problem they gave a point for that. It's a great example of why you just keep working. As soon as you're stuck, you leave a half a page and move on. Half a page of space, so you have space to come back, and then you just move on. Okay, so I got to figure out where g prime is equal to 0. I'm looking right here. Don't get mixed up between g and f. This box is all f, but I'm converting it to g. So let's see. G prime of x is going to equal 0 when x equals, what's the interval here? -2 to 5. So that's good. It's just the graph. -2 to 5. So I'm looking here, here, and here is also an endpoint. So when x is equal to -1, 0.5, and 5. As soon as I do that, right here, the grader expects, I'm moving this box around so we can't really circle things as we go, but so right here, number 4, we are finding the max of g. So the grader wants to see us identify where g prime of x is equal to 0. This is usually worth 1 point, and it was. We've actually earned 2 points so far. It's a great example of just do what you can. You don't know how it's going to be scored. This problem is actually only worth 3, and so far we have earned 2 of them fairly quickly. The justification is what often takes the most time, so if you want to skip that and move on now, it's not a bad choice. Just leave, a quarter of a page space. Okay, so, but finishing, we now have 1, 2, this is an endpoint, so it counts twice. We have 4 candidates. So the candidates are x equal -2, that's an endpoint, x equal -1, x equal 0.5, and x equal 5. So in this one it said there were, this example, 5 candidates, we have 4. The grader, number 6, the grader is going to expect us to eliminate eliminate, in our case, 3 of the 4 candidates. We're looking for the absolute max of G. So look for ways to eliminate candidates. Well, right here, G prime is changing from negative to positive, so G will change from decrease to increase. That's a relative min. That cannot be the absolute max. So it looks like we could eliminate that. So we'll use some words to do that. We can type that one to save a little handwriting here. You'll have to write it out, but so I come up here and I write at x equal 0.5, G prime of x changes negative to positive, so G of x has a relative min at x equal 0.5. That's enough. You don't have to write anything else. The grader will know that, the grader will accept that as sufficient justification that we have now eliminated x equal 0.5 as a candidate. So we move on here, change color. I also notice that for, this one I have to write by hand because I don't have the right symbol here. Hold on. So I also notice that for the interval, starting at x equal negative 2 until I get to x equal negative 1, G prime is positive, which means G is increasing. On that interval. Which means, so G of negative 2 can't be absolute max of G. The idea is quite simple. We don't know what the graph of G looks like. But we know that on the graph of G, at x equal negative 2, there's some y-coordinate. We call that G of negative 2. And beginning at wherever that y-coordinate is, the graph of G is going, let's draw this a little different. Beginning at wherever that x-coordinate is, the graph of G is increasing after that point. So there's no way that this point on G can be the highest point on G. That's what this blue statement is telling you. And so the blue is a successful elimination of this candidate. We've eliminated that candidate, we've eliminated that candidate. We still have to test, we still have to figure out which of these two is greatest, and there's no way to do that other than by performing integrals. So now we would have to do integrals to figure out which of these two is the greatest. We have to go find G of negative 1, we have to find G of 5. So again, that justification point is the third point, and as is typical, there are exceptions, but as is typical, this one is taking a bit of time. So we're going to copy this over. Clear it all off to start fresh. Looking for, let's write that. Let's see, we're looking for negative 1 and 5. So clear everything. Trying to find right here. Let's write down negative 1 and 5. We basically, doing these elimination steps, we've used some words very similar to this. And now we're on item 10. We have two values that need to be found. G of negative 1 and G of 5. We have to use integrals to do that, so we write G of negative 1 will equal the integral from negative 2 to negative 1, that's going forward, that's good news, of f of t. Okay, so let's see, that's going to equal, so from negative 2 to negative 1, f is always positive, that's 1 times 1 divided by 2, that's 1/2. You need the value so we can make a comparison here. Then we go find G of 5. That's going to equal the integral from negative 2. Well, we've done this one already. That's why going slow and careful is important. If you remember, we had to find that integral back here. This one. We didn't find it to be a very nice looking answer. We just have to figure out if it's bigger than 1/2. So we have to go a little further here. Let's see what the... So working this out, we're going to have... And you could pick up your calculator here and just type it in. Just make sure you use 3 decimals. So I'm going to have 7. Distributing the negative, I'm going to get plus 1/4. Minus 3 times 1.5 is 4.5. That's 9/2 divided by 2 is 9/4. Distributing the negative, that's minus 9. That's plus, distributing the negative, 9 pi over 4. So all that's going to equal negative, so 1/4 and 9/4 is negative 8/4, which is negative 2. So that's negative 11. Negative 11 plus 7 is 4, so the answer, so we get this to be 9 pi over 4. Subtract 4. Oh, I made a big mistake. The 7 was not part of what we were finding. We were trying to find this integral. So it's another good example of this last point on this min-max problem is really causing me trouble. So it's 7 more than that, so it's minus 11 here. 9 pi fourths. And it's not minus, it switches because it was this that I was trying to find. So it's actually 11 minus 9 pi over 4. Ouch. I would have definitely lost that point. A good example of where on this test, probably a lot smarter to pick up your calculator and punch that out if you needed it. But anyway, back to here. That does turn out to be bigger than 1/2. So now you just write on your paper the absolute max of G this was left over from the previous page here. Is G of 5, which is equal to 11 minus 9 pi over 4. Yeah, a lot of work for that last point. I would always skip on a min-max problem. I would get to where I start to justify. If the justification goes quick, go ahead and do it. Otherwise, I would skip, leave some space, come back if you have time. It was only one more point for a total of 3 on part C.